In video 27 we're going to look at the third and final character set that we're going to look at in F451, and it's called Ebcdic. So in previous videos on character sets we've looked at ASCII. We looked right through the different character mappings for ASCII. Unicode was the next character set that we looked at. Unicode character mappings are a little bit more difficult to find, but I just came across this really good website called unicodetable.com, and this shows all of the character mappings for the thousands and thousands that there are in Unicode. It actually uses hexadecimal values to store them because there are so many, but it's nice because as you scroll down it, it will help, first of all, look at the control character section, which there are many. But as you move down, it tells you which section you're in. So I'm currently in Basic Latin, and if I hover over any of them as I scroll through, so I'm onto all these different versions of Latin, and you'll see all the different languages coming up as you go through them. If you hover over any of the characters or symbols, it tells you a bit more about them, and also their Unicode hexadecimal value. So that's Unicode character mappings, which I quickly want to show you before we look at Ebcdic. So Ebcdic stands for Extended Binary Coded Decimal Interchange Code. So that's quite a grand title, isn't it? Developed by IBM in 1963 and is used mainly on their mainframe and mid-range computers. Is 8-bit, so 8 bits per character, just like ASCII, but actually the mappings are different. It's just a different way of mapping the characters that are needed. And it does it using binary coded decimal. You might have got that from the title up here. And if you're not sure what binary coded decimal does or is, you should watch video 20. But it's just a different way of using binary to refer to the character mappings from the way that ASCII does it. Now, we just looked at Unicode mappings on the web. Ebcdic mappings are even more difficult to find. astrodigital.org has them. So if you wanted to look them up, there they are. Not very interesting, but you do eventually get down to the alphabet. There we go. So you can find them on the web if you look hard enough. Think about the exam. Again, you're very unlikely to be asked specifically about Ebcdic. Likely to get asked about character mappings in general. You could refer to ASCII or Unicode as examples when explaining how the mappings work. You may get asked about how many bits might be needed for a particular mapping for a particular scenario, and we'll look at some past paper questions now. And thinking about those past paper questions, you might, for instance, when we're thinking about number of bits needed for scenarios, it might be something like how many bits would you need in your character set in order to provide mappings for all of the buttons on a telephone, for example. But we'll look at a different example. Firstly, let's look at a basic past paper question. Explain what is meant by the character set of a computer, worth 2 marks. And you just try and provide a definition for the examiner. It might look a bit like this. The symbols that a computer can recognize or use. Each symbol is distinguishable from all others. Most can be referenced to characters on a keyboard. And you might say that the examples could be ASCII or Unicode. Those are character sets. A more complicated, more advanced question might be, by referring to 2 examples of applications that need character sets of different sizes, explain how codes are used to represent character sets. And you'd get asked for a first example worth 1 mark, a second example worth 1 mark, and then your explanation of their uses of codes for a further 4 marks. So you can see a much more complex question. But firstly, you're asked to give examples of applications that would need character sets, and some good answers might be those. Try and choose 2 different ones, very different ones: a word processor and an ATM, an auto teller machine, or as a cash machine, as we might more commonly know it. Firstly, we're going to explain how the codes are used to represent the character sets for the word processor. So each required character is given a unique binary code. The more characters required, the more bits in each code. For a word processor, one of the following would be used: ASCII, Unicode, or possibly even Ebcdic, but I might try and avoid Ebcdic when answering questions on character sets. So we've covered the word processor one there. Thinking more now about the ATM one. This is quite an interesting question to answer. On an ATM keypad, we'd need 10 digits and maybe up to 6 different other commands, such as clear, cancel, OK, enter, whatever. So that is 16 character mappings are required. Therefore we need 4 bits per character. So how do we work that out? Well, 4 bits allow you to have 16 different combinations, and there they are. So that would be a great answer to give for that second part of that last part of that question. Calculate the number of bits needed for an amount of buttons on a keypad really. So you might practice, say, for the telephone one now. Thanks for watching.